Our last speaker in this session is Richard Bradley from Atkins, who's maybe the only person who put his hand up to who's used HoloLens. But he'll probably tell us about that. But Richard's going to be talking about how you integrate real-time data with models, essentially, and virtual worlds.
Hello, everybody. I'm Richard Bradley, Technical Director at Atkins Intelligent Mobility Team. I'm here to present a modelling roadmap that ultimately leads us to this thing called the digital mesh, where the real world and the virtual world merge into one. Okay, our current modelling processes seem unprepared to me for the planning and designing and operating and maintaining of people's mobility in what seems to be a very uncertain future we talked about earlier. But I think there is an emerging roadmap, and today I'm going to talk about the modelling consequences of what is the fourth industrial revolution around automation and data exchange. A revolution that should be fully realised in about 15, 20 years, and I'm going to talk about the key trends in technology, data and computing that will enable this revolution, and how these trends can ultimately allow us to simulate entire cities, obviously a subject we've been talking about, and what this will mean for the individuals in the real world and also in this new virtual world. Key trends in technology around miniaturization, connectivity and convergence. Technology, as you know, is getting smaller and more powerful and will continue to do so, assuming that we can crack the current issues around battery size. The miniaturization is allowing devices to become almost part of us, and I, for one, will be signing up for the new generation of wearables, the Invisibles, and that's not a joke, by the way. They are real things. Tattoo technology to your arm, and personal connectivity is putting everything at our fingertips, or in our ears, or in our eyes, and this connectivity is just going to keep growing. We talked about the 5G earlier. That'll be getting 12 times faster, and of course, lots of extra bandwidth. Another mobile connectivity around autonomous vehicles, the vehicle-to-infrastructure and vehicle-to-vehicle connections. As well as our own connectivity, the devices that we use will also hook up into our personal system. The Internet of Things, a world of connected sensors, will allow us to connect to every device that we use in the home, while we travel, and during our daily activities. And all this technology is already converging into one small device, and yes, of course, that's the mobile phone. And even now, this has become our personal control centre, and it's fast becoming our personal link to our very own private data and app cloud. So our world of the future will be dominated by API connections between the person and their devices. Every time we communicate with our device and our cloud, we'll generate a network event. Currently, we make about one network event every 5 minutes, and in the near future we can expect that to be many events per minute. And there will be many additional instantaneous events around our safety and collaboration with others in our immediate space. For example, to avoid a collision in an autonomous vehicle, or to quickly form a vehicle platoon. These events might be captured within a black box recorder, no doubt fitted to our autonomous vehicle by the insurance company. But we'll need to aggregate these events for privacy and for bandwidth reasons. For example, facial video analytics might be aggregated to what we might call a state of mind. But combined with the hard facts around the vehicle kinematics, vehicle decisions, autonomous decisions, weather from vehicle sensors and so on, over time we're going to build up a rich picture of our behaviours and the world we move around in. Other data sources rapidly on the rise include digitising the assets that we plan, design, operate and maintain. This includes using drones and geomatics to build a digital 3D model of an asset's surface condition. And by combining these digital models with the asset's BIM model, we'll have X-ray vision using augmented reality devices like the Microsoft HoloLens, and you can see an example on the screen of a bridge that we mocked up. This digital world we're creating is already being used by the likes of TripAdvisor to advertise local amenities when you walk down the street. Of course, there will be many issues as this data and connectivity and technology allows us to fully digitise everything. But these tend to boil down to an individual's privacy versus the technology, versus the quality of the information fed back to them, the time window the data event happens and it being ready for use, and also a universal agreement on a common object model and fast ways to search connected objects. But no doubt we'll deal with these things, and in 10 years' time probably look back and think what all the fuss was. But will the computers allow the practical use of this data? Well, Moore's law on the increase in processing power is still holding true when we project over 100 years. We have the rapid evolution of GPU-enabled technology and high-performance computing, allowing distribution over millions of threads in real time. And the new collaboration between hardware and software using modeling algorithms that are massively data parallel. And we've just produced a new version of Saturn called SatGPU, which is following those examples. Furthermore, the new cloud-based computing is making big data accessible and contemporary data analytics environments. These environments will be used by the modelers to experiment with data of different velocity, variety, and volume, and use machine learning, and for more complex problems, AI, to build alternative predictive models. But we can only predict what we can understand, and we need to build business cases for the future mobility now. Currently, we don't sufficiently understand the short-term behaviours around CAVs. But CAV projects like the Atkins Ventura project are building this understanding, and the human-machine interface and the driver behaviour can be tested in simulators and visualised out on the road using augmented reality. And added to this insight, the current CAVs driving around on the road in the real world are gathering data through dozens of sensors like cameras, lasers, radars, and GPS receivers. This evidence is being collated in simulations like the Atkins Flourish project I'll talk about for a minute. Flourish is building an advanced CAVs rules engine linked to personalisation through an AI system. The Flourish system will be tested in an AIM-SUM simulation, and then in simulators, and then ultimately on the road in the real world. With this rules AI system, we will be able to simulate many different types of personalised CAVs and within many future scenarios. And from this detailed understanding of behaviour, we will build macro models that can be scaled across regional networks so we can understand the macro impacts of CAVs. Applying the CAV behaviour in these macro models will allow us to use to forecast the take-up of CAVs, providing insight on the spatial, temporal and societal penetration. And with this insight, we'll be planning the supporting infrastructure needed to keep the CAVs safe and maximise their operational impact. The supporting infrastructure will include collaborative traffic management, and it was touched on this morning about this collaboration being required to maximise the use of CAVs. So this collaborative traffic management will be able to optimise the transport systems based on the local needs through capacity incentives. Simulating this collaborative traffic management is a key aspect of the Flourish project. So we'll be able to model the behaviour of CAVs and also the systems that are incentivising their collaboration. In the slide, you can see how vehicle data is aggregated from vehicle sensors to a central control system. That determines the best options for the area and then incentivises vehicles into platoons with a traffic signal green wave towards a shared destination. These collaborations need planning and designing for now. Otherwise, we're going to have very selfish CAVs out there from different vehicle manufacturers, and this could probably make the situation worse. And we need to quickly go from planning to operations, switching from the simulated clock to the wall clock. This will require a new generation of models built using artificial intelligence that run in seconds. Every prediction from these models will be fed back from sensors, and the AI will continually improve the model. This not only makes the model self-learning, but also self-maintaining. Flourish will provide our most advanced simulations of CAVs and their collaboration. But do current microsimulation tools provide all the random effects that make the real world so hard to predict? And what about other effects in the shared environment, including people and other modes like cyclists? And that's where we think about more, and that's before we start thinking about more advanced modelling like dynamic activity schedules. And CAVs will help us sweat the assets, no doubt. But many of the decisions are set once people have left their home in their car. Therefore, it's critical that we start getting start to deliver advice on the next hour before people leave the home, and that we provide advice on the complete door-to-door journey, plus likely return travel conditions. To achieve this, firstly, we'll be using big data to break down the annual average into more meaningful contextual scenarios, like heavy rain in November, then use real-time data collected from sensors and vehicles to account for more detailed variation. The data will then be used to predict more reliable advice on travel options using this new generation of models built and maintained using AI. And we can also use the data to build predictive tools to ensure intelligent mobility services are at the right time and the right place. And this is the new role we've identified that we're heading towards, the role of the strategic commander. It requires our strategic planning processes to be re-engineered into this real-time system and use the wide range of sensors and vehicle data combined with data from mobile devices and the Internet of Things to provide a more complete picture in real time on air quality, on noise, on safety, economic impacts, or whatever is valued locally. And we have a vision of providing this advice like a weather forecasting service, and even looking 2 or 3 days ahead. But maximising benefits of CAVs and other concepts like mobility as a service needs to tackle the long-term ownership behaviour. As well as getting advice into the home, we need to use the data insight in a planning context to encourage relocation and demonstrate the benefits of not owning a car. Again, we'll turn to data and models to build business cases for incentives to drive this change. But driving our current sustainability strategy seems to be pinned to electric vehicles and intelligent mobility. But I think this is unlikely to be the ultimate solution, as the root cause is overpopulation. If our populations continue to grow, our ultimate survival strategy has to be to keep evolving our urban planning system as the new data insight comes online. So we need to maximise the long-term impact of intelligent mobility by ending car ownership and concentrating populations on more efficient urban environments. But how do we truly build into models all the randomness represented in the real world? How do we add the many layers of detail represented in our city's complex interactions? Well, when we look to other industries, we see defence, and we see this thing called the high-level architecture, the HLA, and it's very popular for collaborative simulations. And it seems that contemporary data and computing will enable holistic HLA city simulations. But how do we get started now? Well, data being used in our development of the new national transport model has data and analysis on individual properties as a key building, which is a key building block to a population synthesizer, which in turn gets us closer to simulating all the people or agents in a city. And the GPU-enabled technology is already being used to give a separate thread to every agent, allowing each agent to act under their own personal set of rules. So it might not be long before we see the city simulations of each agent having their own activities to think about and manage. But no single simulation can solve a city's complex problems. So we'll use advances in connectivity with high-speed web APIs connecting the Internet of Simulations. The Internet of Simulations will see service providers like Atkins will be able to plug in our services to simulate city services and resources and their interaction with the city's population. We'll be able to play many scenarios and model different roles in society. And one that really interests me is to put the different politicians in power and see how the city evolves. And each simulation can be linked to other simulations, city simulations, creating a wider web of city interactions. And when we've got the real world understood and fully digitised, with interactions of agents and services simulated, what does this look like for the customer? Well, I've talked about the strategic commander, and I've talked about the role of predictive tools and collaborative traffic management. The next step will be to submerge the user in this digital world we've created. This merge of real and virtual worlds is called the digital mesh and has been identified by Gartner as a key future trend. The digital mesh is people-centric, with the collection of devices, information apps, services, businesses, and other people that exist around the individual. As the mesh evolves, all devices, compute, and information resources, businesses, and individuals will become interconnected. The highly connected individual of the future will be travelling in their personalised digital data bubble, linked to their personal cloud, and as a modeler, all the time generating data. Their preferences and personal advice will follow them as they get in and out of different cavs. And Gartner defines the economics of connections as the creation of value through increased density and interactions between business, people, and things. As an organisation increases the density of its connections, it increases the potential value it can realise from those connections. And the businesses that operate in this space will become fully algorithmic businesses, with business decisions completely automated. But I'd like to end on our recent experience with the financial sector going algorithmic. After this experience, maybe we should keep one or two humans in the loop. Okay, thank you.